In this video, we're going to have a look at how to calculate two-step probability questions using tree diagrams. Now, two-step probability questions involve two events happening. So for example, you could roll a die twice, you could flip a coin twice, or you could roll a die and then flip a coin. Each of those are examples of two-step change probabilities. So you can calculate the probability of an outcome involving both events when you do two-step chance probability calculations. And one way of completing those calculations is drawing a tree diagram, which helps you to determine the possible outcomes and then assign probabilities to those outcomes. So let's have a look at an example. In this example, we have two bags that contain coloured counters. In a probability experiment, one counter is to be selected at random from each bag. So we want to show the sample space using a tree diagram. So to do that, we start off with the first bag. And in the first bag, I have three possible colours. So I need to draw a tree diagram with three options: red, green, and yellow. Then for my second bag, I've got a black and a white. So if I draw a red from the first bag, from the second bag, I could then draw a black or a white. If I'd done a green from the first bag, I could still do a black or a white from the second bag. And if I'd done a yellow, again, I could draw a black or a white. So my tree diagram lists the first bag and the options from the second bag. So combining the options from the first and the second, I can have a red and a black, or a red and a white. I can have a green and a black, or a green and a white, or a yellow and a black, and a yellow and a white. So looking at all my possible outcomes, I have got 6 outcomes that are possible from the combination of the first and second bags. So to calculate the probability of each outcome, I'm going to go and assign probabilities to each step in the tree diagram. So from the first bag, when I draw a red, a green, or a yellow, there's 3 options and each one is equally likely to occur. So the probability of drawing a red counter is 1 over 3. The probability of a green counter is 1 over 3. And the probability of a yellow counter is 1 over 3. Doing the probabilities for my second bag, I got a black and a white. So the probability of drawing a black counter is 1 over 2. And the probability of drawing a white counter is 1 over 2. And I can apply that probability to each of my black and my white options. So now I can go ahead and calculate my final probabilities for each option. And I do that by multiplying the probabilities together from the tree diagram. So to calculate the probability of a red and a black, I calculate the 2 probabilities occurring. So that is going to be 1/3 times by 1/2, which equals 1/6. So the probability of getting a red and a black is 1 over 6. Now, because all of my options are equally likely to occur, the probability is going to be the same for each of my possible outcomes. So the probability of each outcome occurring is 1 over 6. Now, you'll note that out of all my possible outcomes, if I add all the probabilities up together, it is going to get 6 over 6, or 1. So I know that my calculations are correct, because if I add up all of my probabilities for each outcome, I get to 1, which is what I should be looking for when I add up all my probabilities from a tree diagram.